Today, we're inside a high-tech factory to see how laptops are made from start to finish. Thanks to this state-of-the-art automation, we're able to produce the next generation of laptops faster than ever before.
Here, pure silicon is melted at extreme temperatures to create the foundation of laptop processors.
Check the resistivity levels on the last batch.
Holding steady, but the thermal gradient is shifting slightly.
The solid silicon ingot is sliced into ultra-thin wafers that will become laptop processor chips. Each silicon wafer is polished to an ultra-smooth surface, essential for building powerful laptop chips.
The uniformity metrics are holding steady at 99.8%.
Confirmed. The edge exclusion looks good as well.
After polishing, the wafers are carefully cleaned to remove even microscopic contamination. Here, the wafers enter a high-temperature furnace, where a protective oxide layer is carefully grown.
Now the circuit design is developed onto the wafer, forming the foundation of every laptop processor. Extreme heat strengthens the silicon crystal structure for maximum chip performance.
Check the deposition rate on sector gamma. It's unstable.
I see it. Rerouting the gas flow now.
Here, ultra-thin metal layers are deposited to create the electrical pathways of the laptop processor.
This step perfectly smooths the wafer surface, preparing it for the next layer of laptop chip circuitry.
Here, every chip on the wafer is electrically tested to ensure it meets laptop performance standards.
Check the yield on block 4. Still seeing some failures there.
Overall result is within tolerance. Let's move to the next sequence.
At this stage, chemical and mechanical polishing makes the wafer perfectly flat for advanced chip layers. At this stage, chemical and mechanical polishing makes the wafer perfectly flat for advanced chip layers. Here, each individual chip is mapped and tested to identify the most efficient and functional dies. At this stage, the silicon wafer is carefully cut into thousands of individual processor chips.
The alignment on the x-axis looks precise.
Confirmed, we are maintaining the target separation yield.
At this stage, the processor die is permanently bonded to its base for electrical connection. Here, microscopic gold wires connect the chip to the outside world.
Keep an eye on the second bond parameters here.
Noted. Quality check passed on this unit.
This protective underfill strengthens the chip and absorbs mechanical stress.
This encapsulation seals the chips, protecting them from heat, moisture, and physical damage. Packaging trim gives each chip its final shape, ready for real-world devices.
Every CPU is tested under real workloads to guarantee speed, stability, and reliability.
Before fabrication begins, every GPU wafer is carefully inspected at the microscopic level.
Lithography transfers billions of transistor patterns onto silicon with atomic-level accuracy. Plasma etching carves billions of microscopic pathways that form the GPU's brain.
Atomic thin layers are deposited with extreme precision, forming the foundation of GPU performance.
The finished wafer is carefully sliced into individual GPU dies, each one destined to become a powerful processor. Here, the GPU die is permanently bonded to the substrate, creating a single high-performance processing unit. In this stage, ultra-thin material layers are deposited atom by atom to build NAND memory cells. Here, NAND memory chips are sealed and protected, transforming fragile dies into durable storage devices.
Here, a thin copper layer is laminated onto the PCB to create conductive pathways.
This photomask transfers the exact circuit design onto the PCB using ultraviolet light.
Chemical etching removes excess copper, leaving only the designed circuit paths. High-precision drilling creates microvias that connect circuits across PCB layers.
A solder mask is applied to protect copper traces and prevent short circuits during assembly.
Silkscreen printing adds labels and markings to guide accurate component assembly.
Each PCB is carefully inspected under microscopes to catch even the smallest defect. Solder paste is precisely printed onto the PCB pads to prepare for component placement.
High-speed robots accurately place thousands of tiny components onto the PCB in seconds.
इस स्टेप में पीसीबी को मोल्टन सोल्डर वेव के ऊपर से पास किया जाता है, जहां थ्रू होल पिन्स स्ट्रॉन्ग इलेक्ट्रिकल जॉइंट्स बना लेती हैं।
इस स्टेज पर ऑटोमेटेड सिस्टम सीपीयू सॉकेट को पीसीबी पर परफेक्ट अलाइनमेंट के साथ इंस्टॉल करता है। इस प्रोसेस में जीपीयू चिप को हाई टेम्परेचर सोल्डरिंग से पीसीबी के साथ परमानेंटली बॉन्ड किया जाता है।
इस स्टेप में वीआरएम कंपोनेंट्स इंस्टॉल किए जाते हैं जो सीपीयू और जीपीयू को स्टेबल और कंट्रोल्ड पावर सप्लाई देते हैं। इस स्टेज में रैम स्लॉट्स मदरबोर्ड पर माउंट किए जाते हैं, जहां से सिस्टम को हाई स्पीड मेमोरी कम्युनिकेशन मिलती है।
यहाँ M.2 स्लॉट इंस्टॉल किया जाता है जो मदरबोर्ड को अल्ट्रा फास्ट NVMe स्टोरेज सपोर्ट देता है।
यहाँ मदरबोर्ड की ऑडियो सर्किटरी असेंबल होते हैं,
जो क्लीन और नॉइस फ्री साउंड आउटपुट इंश्योर करती है।
ये फैन कंट्रोल पीसीबी टेम्परेचर के हिसाब से फैन स्पीड रेगुलेट करता है, सिस्टम को कूल और स्टेबल रखता है।
Here, robotic precision bends raw metal into the strong backbone of modern machines. A CNC mill carves raw metal into perfectly engineered precision parts.
Precision CNC machining creates perfectly aligned ports for seamless device connectivity.
High-speed sanding smooths the chassis surface for a flawless premium finish. The chassis is anodized to enhance durability, corrosion resistance, and rich color finish. Keycaps are precision molded to ensure uniform feel, durability, and perfect keystroke consistency.
In the final stage, skilled technicians assemble and inspect each keyboard to ensure flawless performance.
Next, the touchpad is precisely bonded, ensuring smooth response and perfect alignment.
Individual battery cells are laser welded into a powerful, unified battery pack.
Here, the OLED display is permanently bonded to the device, creating a flawless visual interface. Here, the high-speed SSD is carefully installed to deliver lightning-fast data access and system performance. In this step, the Wi-Fi module is installed to enable fast and reliable wireless connectivity.
Cables are precisely routed and locked in place to ensure stable power and data flow.
Here, the motherboard is securely mounted, forming the foundation of the entire system. The hinge is securely mounted to ensure smooth movement and long-term durability.
The display is carefully attached, aligning perfectly with the hinge mechanism.
The laptop powers on for the first time, confirming all systems are working. The laptop powers on for the first time, confirming all systems are working.
The operating system is installed simultaneously on multiple laptops through automated imaging.
All required drivers are installed and verified for full hardware compatibility.
All essential accessories are carefully packed to ensure a complete out-of-box experience.
Each finished device is securely boxed and prepared for safe global shipment.
Thousands of finished units move through the final boxing line, ready for worldwide delivery. Robotic systems automatically palletize finished products, preparing them for rapid global shipment.